All right, here we go. Okay, we're live. All right, everybody, so let's get started. Okay, so I'm gonna take attendance and let's get started with Melwood. Okay, this should all be in your notes from last week. We reviewed all this last week. So you can get all this off the top of your head, but you're in really good shape. Otherwise, I suggest looking through your notes. Take about another 30 seconds. Okay, is everyone ready? All right, let's try it out. So, Curtis, since you look so confident, what's the shape of any even root function? Excuse me? So that's an even degree function. What about even root function? Remember anymore? Okay, that's why we should go back to your notes, right?
Does it go like this?
Yes. Okay, so it's like I'm gonna call it a swoosh. It's like a swoosh, right? So it's basically half of a sideways parabola. That's because it's an even root. The even root is the inverse of an even degree, right? Even degree has that U shape. What about odd root? Just kind of trace it with your finger. Ready? Right, so it's going to be a squiggle like that, right? Squiggle like that. And then here is the origin. If you remember, the origin is right in the middle. And then the origin here is going to be over here. Okay? All right, now in the standard form, which is down there, that's the standard form of a radical function. What transformations do a, h, x, and k determine? So let's start with the easy ones. What about k? What does k determine? Yeah, it's going to be vertical. So vertical shift, right? Up or down. What about your h? What does h determine? What's it called?
Horizontal.
Horizontal shift. Alright, and then your a, so let's start with the absolute value of a. What is the absolute value of a determine? Okay?
Stretch or compression?
Yeah, so it's going to be a vertical stretch or vertical compression, depending on the absolute value, right? So if it's greater than 1, it's going to be a vertical stretch. If it's between 0 and 1, it's going to be a vertical compression. What about negative a? What's negative a? Or vertical reflection. Vertical reflection, very nice. Then the tricky one we learned about was the x, right? So it's if you have a negative or minus sign in front of the x, okay, either h minus x or h minus x something, what does that become? Horizontal reflection. Okay, very good. All right, and notice how this applies to both even root and odd root. So square root and cube root, it applies to all of them. Okay, so you don't have to worry about the differences because the shape of the graphs are different, but this applies to both. Okay, so bring any bells from last week? go over our weekly overview, and then we'll start for today. Alright, so we're in week 17. This is Power Up week. So, quick reminder for everybody, if you didn't know, there's only 2 more weeks of Power Up. This week and next week. After that, there's 3 weeks left to school, but there's no Power Up. Alright, so if you have any homework assignments, I highly recommend checking Power School. If you're missing any homework assignments, you can come to my Power Up anytime during this week or next week. So that's it. After that, there's no more Power Ups, okay? And I noticed that last week, a lot of you, who here went to prom? Okay, so if you went to prom, you're probably too busy thinking about prom, you didn't do your homework, which is fine, I understand. Okay, so if you didn't do your homework last week, come to Power Up, and I'll open it up. Okay? And of course for every one of you, not just for you. Alright, so what we're going to do this week, today we're going to do limits of radical functions. So limits means the domain, range, increasing, decreasing, min, max, all that stuff, which you already know about, right? Okay, tomorrow we're going to do a review of activities, probably going to play a couple of wickets, maybe a hoop. Wednesday we're going to review graphs of radical functions. We're going to take our quiz in class. Thursday, review the quiz, take our next 4 minute. Friday, we're going to do a team building activity day. So you guys remember in 3rd quarter, we did that one day where we just played games and stuff? And we're going to do that again, okay? It's a nice little way to finish. Alright, most likely, I'm thinking about, if you are, most of my classes are getting this pretty good. Who thinks this is a pretty easy standard so far? Okay, so I haven't decided yet, but I'm not sure if I'm going to assign any homework this week, okay? So it seems like everyone's getting it, then I don't think there's any point in assigning homework if everyone's getting it. So I'll decide later on this week. Okay, but this is our agenda for the week. Any questions? Okay, so let's continue with today's topic, the limits of radical functions. Okay? Alright, so first, let's take a look. So I want you to take 2 minutes, think about these 3 questions regarding this function right here. Notice how it's a square root function. Try not to graph it. Okay? Try using your notes, what we learned, to answer these questions. Okay? If you're done, discuss with your neighbors, so you have the same thing. Come here, everybody. That's 2 minutes. So let's see what we got. Alright, so first question, what's the smallest value for x that will result in a real solution here? What's the smallest value for x? Somebody's got to have an opinion at least.
2.
2, okay? So x has to be greater than or equal to 2, right? And how'd you get that, Thomas?
Set what's under the radical equal to 0.
Okay, so you set the radicand equal to 0, right? So underneath the radical, we call that the radicand. Okay, and you set that equal to 0 and you solve and it's got to be 2. So, well, how do you know it's got to be greater than 2 or equal to or greater than 2?
Because that's what you have to plug in for it to equal 0. It's positive 2.
Okay. Well, so you did it correctly, but what's the logic there? Adam?
Because if not, it would be negative.
Okay, very good. So remember, the whole definition of real solution is that in this case, you can't have a negative inside the radical, right? So the radicand can't be negative. So the only way to do that is for your x to be greater than or equal to 2. Okay? So what does that mean? Think about the domain now. Remember, domain is all possible values for x. So is your domain going to be plus or minus infinity? If here it says your x has to be greater than or equal to 2, obviously your domain is not going to be unlimited, right? It's got to be restricted. Here is the restriction. So saying that x has to be greater than or equal to 2 for your domain. Make sense, everybody? Okay. Is this function increasing or decreasing? How can you tell? Just by looking at the function. So first of all, what happened here? So we're looking for some reflections, right? So what kind of reflections do you see in this function without graph? So Mia, what kind of reflections? Vertical reflections. So trace with your finger what the graph looks like. Okay, very good. So the graph's going to look something like this, right? Everyone agrees? It's a vertical reflection. So if that's the only reflection, is this function increasing or decreasing? Marky, decreasing, okay. And how do you know it's decreasing? Well, how do we read increasing, decreasing? Is it left to right or right to left? Left to right, right? So we'll see that if we go left to right, notice that the function is decreasing. Okay, so we always read left to right, regardless of whether or not the function is going a certain direction. Everyone see that? Okay. And lastly, does this function have a minimum or a maximum? Just by looking at the shape, you can be able to tell. Does it have a minimum or a maximum? Natalie?
Maximum.
It's a maximum. Okay. So it's a maximum because the graph can't go any higher than that, right? And can you guess what the maximum is going to be? On the function? It's going to be?
8.
Yeah, y equals 8, right? Because this determines your vertical shift, right? The k value. So this is where everything shifts from, that origin. So if that goes up 8, that means it can't go any higher than 8. This is the maximum. You want to say that? So that's basically what we're going to learn about today, is how to determine all this stuff in radical functions. Okay? All right. Okay, so let's start with domain and range first. So for square root functions, your domain is going to be restricted by the radicand. Okay? So the radicand is everything inside the radical, what Thomas said earlier. Okay, so your x minus h or your h minus x, however it's structured, it's got to be greater than 0. Okay, so how do you find it? First, you want to identify the smallest or largest possible value for x. Just remember, it cannot be the radicand cannot be less than 0. So you got to figure out what value, what's the biggest or smallest value for x, That's gonna result in a positive radicand. Okay, and from there, it's easy. Now you just graph, if you need to, or check the direction of the graph. So once you know what your domain restriction is, then you just graph it, or you check the direction of the graph. And here's where you gotta be careful though. So your graph looks like that. Obviously, your domain is going to be from some value to positive infinity, right? But if the graph looks like this, you know it's going to be from negative infinity to some value. Okay, so that's why it's important to graph it or to identify what the direction of the graph is, because it's not going to be plus or minus. It's going to stop or start somewhere. Okay. Now your range is going to be restricted to your origin. So whatever your origin is, the y value of your origin, and that's what the restriction is. All you have to do is look at your k value. So your k value is going to tell you what your min or max is, but it's not going to tell you which one it is. All you know that it's going to be one of the two, right? So here's where you have to graph and check the direction of the graph as well. Alright, so similarly, if we look at this graph, you know that this is going to be your minimum, right? So looking at the direction of the graph, this has to be your minimum because the graph's going this way. Range we always read from bottom to top. Now in this graph over here, same thing, it's got to be a minimum because the graph is going up, right? But we have a graph instead of going like this, you know that that's got to be your maximum. Okay? And we'll see that. So it's kind of more just like common sense at this point. But identify your k, then graph it, and you should easily be able to see what the min or max is. Okay. So what we have to do in this case though, we have to use brackets for domain and range limits. Okay? So obviously you don't use a bracket for plus or minus infinity because we don't know what infinity is. But in radical functions, you know that a certain value, your x has to be a certain value or higher, right? And it includes that value. So that's why we use the brackets. We'll do a little bit of practice with the brackets here. Alright, so that's for square root functions. Now, can anyone think about even root functions? For even root functions, specifically cube root functions, what do you think the domain and range is going to be in a cube root function? Think about the shape of a cube root function. Ready? Okay, very good. So, because of the shape of a cube root function, cube root function is always going to have this shape, right? It could be flipped. But either way, it's always going to have that shape. So you know that your domain and range are both going to be plus or minus infinity, always. Okay, so this one's easy to remember. So the logic behind this is, think about the graph shape, right? It goes this way and that way forever, it goes this way and that way forever, right? Left to right forever, down to up forever. Okay, so now let's talk about mins and max. So for square root functions, as I mentioned earlier, so your minimum or maximum, it depends on your k value. So your k will determine what the value is, what the value of the min or max. It's not going to tell you which one is that. You got to look at your a to determine whether it's min or max. Okay? So all you have to do is look at the negative sign in front of the a. So let's think about that. In a square root function, if your a value is positive, the graph shape is going to look like this, right? Like that. Your a is positive, right? Or it's going to look like this. If your a is positive and your x is negative, right? Either way, this graph, does it have a min or a max? Either way, either this one or this one. Does it have min or max? Any other?
Max.
It's a max. Are you sure it's a max? Here. Right down here, is it a min or a max?
Min.
It's a min. Okay? Everyone see that? Okay, so your a value is positive, there's going to be no vertical reflection. You could have a horizontal reflection depending on your value. Okay? But it's always going to be a minimum. And the other way, it's going to be a maximum. Because your graph flips, right? Vertically. So your graph could look something like this now. Like that. Or it could look something like that. Okay? One of the two. Just remember, if your a is positive, it's going to be a min. If your a is negative, it's going to be a max. Everyone got it? Very good. Alright, so for cube root functions, because there's no range limit, what do you think the min and max is going to be? If there's no limit to your range, the graph goes forever up and down, left to right, what's your min or max? Richard, what do you think? There is none, right? So there's going to be no min or max for cube root functions. Alright? So that's all you got to remember, there's no min or max. Alright, so that's it for min and max. Everyone okay with this? Very good? Very good? Very good? Good?
What? Yeah.
You sure?
Yeah.
Alright, wow, that's a lot of notes.
I wrote everything you had on the slide.
Okay, great, thank you. Alright, lastly is increasing and decreasing intervals. So let's do the same thing here. Let's think about the shape of the graph. And it's going to be the same for both cube root and square root functions. It's going to depend on your a and your x value. Okay? Whether or not you see a negative sign in front of the a or the x. That's all that really matters. So we'll do the easy one first. If I were you, I'd copy this table down so you can fill in the table. Okay, so let's start from your positive a and positive x. Okay? So let's say you don't see a negative sign in front of the a or the x. So in that case, you start with the square root function. Square root function is just going to be like this. Right? And then a cube root function is going to look like this. So either way, in either case, is the graph increasing or decreasing? When a and x are both positive. William, what do you think?
It's increasing.
Increasing, right? It's increasing. I'll have to put that in. increasing because we always read increasing, decreasing from left to right. If you go from left to right, you'll see that the graph is indeed increasing for square root. It's also increasing for cube root. Okay? Alright, so now that we have that, I want you guys to fill in the rest of this table. So take a minute to think about it, the shape of the graph, and fill in the rest of that table. Okay, once you fill in the table, check with your neighbors, see if they have the same thing.
These two are facing each other. These two are facing each other.
And then for negative a, we probably have to.
There's only two variations.
Oh, there's only two. That's why I'm confused. Then there's
Because since it's in the middle, it reflects this way, and this way is
oh yeah.
Okay, so let's see what we got here. So remember, this applies to both, right? It's going to be the same for both square root and cube root. What about when your a is negative and your x is positive? When your a is negative, x is positive, you're only going to have a vertical reflection, right? So is the function going to be increasing or decreasing? Nevaeh, what you say?
For negative a, positive a, decreasing.
Okay, decreasing. What else got decreasing? What about over here? Thomas, what you do?
I got increasing.
You got increasing?
Yeah.
Let's think about this, guys. There's a vertical reflection, and that's it. There's no horizontal reflection. The graph is going to look like this. For a square root, for a cube root, it's going to look like that. Now, if you read left to right, are these graphs increasing or decreasing? They're going down, right? So they're decreasing. Yes, there you got it right. Okay. All right. Now, what about when your a is positive and your x is negative? So in this case, you're not going to have a vertical reflection. You're just going to have a horizontal reflection, right? So let's look at the graphs again. So the graphs, it's going to be looking like that. Or it's going to be looking like this. So either way, if we read left to right, what's happening? Abigail, what's happening? Your a is positive and your x is wrong.
One's increasing and one's decreasing.
Look at it carefully. We read left to right. What's happening to the graph?
Decreasing.
They're both decreasing, right? Everyone see that? So don't get confused with this arrow. Okay? We always read left to right for increasing, decreasing. So if you read left to right, the graph is decreasing for both. Okay? And then the last one, you do the same exercise. So Tamia, what do you think the last one's going to be? It's going to be increasing, right? So let's draw these graphs as well. So here, you just have a negative a and a negative x. You're going to have a vertical and then a horizontal. So your graph's going to look something like that. Something like this, right? And then here, with your cube root function, a vertical and a horizontal reflection, they cancel each other out. you're just gonna go right back to the original shape. Now both of these, if you read left to right, are increasing. Okay? Make sense, everybody? Okay, so let's put this in practice now. Let's take a look at this graph. Okay? So just by looking at the graph, what's the domain, what's the range? So this is obviously a square root function, right? It has that swoosh shape. What's going to be your domain and range? So start with the domain. Ethan, what do you think the domain is?
0 to infinity.
0 to infinity. Not that 0 to infinity. Everyone see that? Okay. The reason why I'm putting a bracket is because your x can be 0. Remember, you can take the square root of 0. That's fine. It just can't be anything less than 0. So it's 0 to infinity. That's your domain. What's your range here? Range will be from bottom to top. Anna, what's going to be our range?
Range is bottom to top.
Bottom to top. So it looks like the origin's right here.
5 to infinity.
Very good. It's the same thing. We do that 5 in the bracket to infinity. Your range. We'll see. Okay, so always start from the origin for your range, domain. What is the min or max? Yeah, what's going to be your min or max? Tell me the min or max. Which one is it?
Oh, minimum.
It's a minimum. And where does that occur? Y equals what?
Y equals 5.
5. Okay, so notice how your minimum is the range limit. Okay? Your min or max is going to be your range limit. You just got to know what direction it goes. Is this function increasing or decreasing? You said that? Very good. Say that.
Increasing.
Increasing. Everyone see this increasing? Right, from left to right, it's increasing. And lastly, what could be the values for h and k? So we know what the origin is. So your h determines your horizontal, right? Is there a horizontal shift here? No? I don't see one. So Richard, what's your h value? 0. And then what's your k value? Marky, what's going to be your k value?
5.
It's going to be 5. You guys notice something? To find the h and k? What do you have to look for? Find your h and k. What are we looking at? To find this?
Intercept.
Not the intercept, because it doesn't necessarily have to be an intercept.
Or the y value.
It's going to be
Is it the origin?
the origin. All you have to do is look at the origin, okay? Origin will tell you your h and your k. You want to see that? You see what it does. Okay, lastly, x and a, are they positive or negative here? So look for some reflections. Do you see any reflections? Santi? So, are x and a positive or negative? They're both positive. Okay? You can be able to see all these things just by looking at the graph. If you can do this, you're going to be in really good shape for the test, okay? Alright. So, here's an example of a cube root function. So cube root function is a bit easier. I'll mark the origin for you guys. The origin is, that's going to be your origin. Okay? So, cube root function now. What's the domain and range? Emiliano, what's your domain and range?
Negative infinity to positive infinity.
Okay, good. So they're both negative infinity to positive, right? So they go on forever. Go sideways and up and down. Min or max? Tyler, min or max? None. Because domain and range are both positive and negative, right? Increasing or decreasing? Which one is it? answer right, the graph is obviously going down. And what's all the transformations? Okay, so let's start first with the origin here. So the origin looks like it's, what's the origin, by the way? What are the coordinates of the origin? Yeah?
9, 4.
9. Looks like 9. Okay, you want to see that? So we determined earlier, your h is your 9, your k is your 4. So what happened? How much did it move right? Adam, how many units did it move right?
9.
9. And we went up. All right. 9, right, up 4. Any other transformations that you see? Madison? So it could be a horizontal reflection or it could be a vertical reflection, right? Because in a cube root function, horizontal reflection and vertical reflection are the same thing. Everyone remember that? So if you have one or the other, they're going to look exactly the same. If you have both, there's going to be no change. Okay, lastly, now that we have all this information, let's try to construct a function. Yes.
Do we know if it's horizontal or vertical reflection from this?
That's what we're going to do next. Okay? So let's take a look. Let's see, construct a function here. Assuming that your a is 1, your absolute value of a is 1. Okay? Let's construct the rest of the functions. We know what the h is. Your h is 9. So it could be x minus 9. And your k is 4, right? Positive 4. Okay? And then we know we have a vertical reflection. So let's call it a vertical reflection first. So you know it's going to have a negative sign in front of it. So that could be a possible function, right? Everyone agrees? Now what happens if instead of a vertical reflection, it's a horizontal reflection? Because it's going to be the same thing. Let's write the function now. Thomas.
Positive 1, and then under the radicand, negative x minus 9 plus 4.
Negative x minus 9 plus 4. Okay, everyone agrees with Thomas? Or you could write this in a slightly different way. How else can you write this? I mean, it's correct, but how else can you write that? Very good. How else can we write this? Just to write it.
Positive x, positive 9. I don't know for sure.
Look careful. I'm going to help her out.
What question? 9 minus x.
9 minus x. Thank you. 9 minus x is the same thing as negative x minus 9. Everyone agrees? You're just swapping it around. This is the way we're used to seeing it. I haven't really shown you too many of these. What's the same thing? Negative x minus 9. I'm sorry, negative 9 minus x is the same as negative x minus 9. Okay? So either one of these could be the function. Let's see that. So we just constructed a function based on just by looking at the graph. Okay, you will see some of these on the test. That's why we're going over it now. Okay, everyone feel comfortable? Who's got this? Raise your hand. Lydia, you got it? Brianna, you think you got it? Okay, so why don't you guys try one on your own? So take a look at this graph and do the same thing. Identify all this information and then try to construct a function assuming that your absolute value of a is 1, okay? Let's try that. Alright, buddy, if you're done, check with the neighbors. Alright. So, let's see what we have. Domain and range. Start with the domain. Dakota, can you tell us the domain, please? Okay, so negative infinity to 2. We'll use that bracket for the 2, right? What about the range? Can you tell us the range? Okay, so it's going to be from 3 to positive infinity. Alright. Nice. Okay, what's the min or max? What's the min or the max? Wait, what is it? Okay, what is it? Y equals what? Y equals. Okay, so it happens to be the same as your range limit. Increasing or decreasing? Santi, is it increasing or decreasing?
Decreasing. Decreasing.
Decreasing. Okay, so we look left to right, the function is decreasing. Now let's try constructing the function here. Who wants to give this a shot? We have all the pieces. Your origin is 2, 3. So now we know what to stick in for your h and k, right? Try it out. Caitlin, can you try it out? Okay, 2 minus x plus 3. Everyone agrees? So there's a horizontal reflection, right? Okay, so it could be 2 minus x plus 3, but like we did earlier, it could also be negative x minus 2, right? It could be either way, but this is the way we're used to seeing it, so let's just keep it like that. Okay, everyone think they can do this now? Constructing functions? Okay, let's try one more then. Okay, so try this. Let's try number 2 next. Okay, if you're done, check with your neighbors. begin. Domain and range. You can help us with domain and range. There we go. Can you help us with domain and range, please?
Yeah, it's gonna be negative infinity for domain to 2,
Okay.
and then range will be negative infinity to positive 4.
Okay. Alright, go. Is this a min or a max? What is the min or max?
There's a max.
Okay.
Y equals 4.
Y equals 4. Okay. Increasing or decreasing? Tyler?
It's increasing.
It's increasing, okay? So don't let this fool you guys. Notice how the arrow goes this way, but we always read left to right. So it's actually increasing. And it stops increasing right up here. So it's increasing. Now let's construct a function. So you know what your origin is. The origin we determined is right here, which is 2, 4. So you know your h and your k values, and you also see a couple different reflections here. Okay? So what's going to be your function, assuming that absolute value of a is 1? Any brave souls want to try it out? Yeah, yes.
Would it be negative 1 square root of 2 minus x plus 4?
Perfect, very nice. You want to see that? Okay, so your a is negative, your x is negative. Okay, your 2 is positive, which is that way. And your 4 goes up. Okay, so this would be the function of this graph.
Why would your minimum and maximum be like just the number? Like, why wouldn't it be the point stuff?
Okay, so remember we learned that the min or max, it's always expressed in terms of y, because that's all we're evaluating, it's just your y value, right? So it doesn't, the x value, it doesn't have any influence on what your min or max is, it's just your y. So sometimes you might be asked, what's the minimum point or the maximum point? If that's the case, then you would say the point. But just general min or max is just going to be expressed as y. Okay, if everyone got this, raise your hand if you got all the information here, especially this one. Okay, pretty close to it. Okay, all right, good job. Let's do our closure and then we'll be done. Okay, so first question, think about it carefully. What determines the domain of a square root function only? Okay, who says A? Raise your hand. B, C, D. Who's not sure? Okay, let's think about it. The domain restriction of a square root function. A value. What does A value do? Vertical reflection, right? Does that have anything to do with the domain? Nope. The K value. It moves up and down. Does that move anything have anything to do with the domain? It's gotta be this one, right? Just the radical. It's gotta be greater than 0. Okay, let's not back up, please. Let's finish up. Okay. Now, which of the following is not true regarding cube root functions? So think about the shape of a cube root function. So it should be a little bit easier. Who says A? B? C? Okay, that is correct, because the function is always either going to be increasing or decreasing, right, depending on your A value. Alright, here's today's trivia. What's the most covered song of all time? Good music. Who said this? Elvis Presley. Frank Sinatra. Chuck Berry. Yesterday by the Beatles. Hey, it's the Beatles. It's the most covered song of all time. Okay, everyone. So tomorrow we'll do a bit more practice with activities. Okay?